Okay, in this example, I'm going to be using the free OEM auto information from Motor EBSCO through my public library to help me diagnose a problem I'm having with the blower motor on the '05 Tahoe is not quite working for me. Um, so to learn how to get access to this stuff, check out my other video on how to get free access to OEM auto information. All right, so it's an '05 Tahoe. Let's get that up and going. Chevy Tahoe. And the problem that I'm having with it is with the blower motor for the HVAC system. So there is no DTCs. I already scanned and looked for DTCs, so I couldn't find anything there. So I'm going to have to do it the hard way. It's not too hard. Is I'm going to have to do some diagnostics, maybe with just a voltmeter here. And so this is not so much about me actually going through all of those steps and showing you exactly how I repaired it, but it's more about how did I use this information to assist me in the repair. So when there's anything electrical and there's no check engine light or DTC code, it's time for me to go to two things. How the whole system works, description and operation, and then the wiring diagram. So I want to go to description and operation first to be able to get an idea. So I'm just going to just type in blower and do a search there, and then I'm going to go to description and operation, and it says air delivery description and operation, and mine's the automatic one. So I'm going to just click on that, and here it has a full information of how that whole thing blows air basically and how it controls with the doors and everything like that. So in my case, I kind of read through here and I discovered here that there's a blower motor control processor which controls the speed, and an HVAC control module which sends a signal to it and to tell it how the speed is adjusted. So I'm like, okay, well, that's useful information, right? We've got the HVAC controller sending a signal to the blower motor controller, which changes the voltage on the blower motor controller. So, okay, so it could be the blower motor's blown, could be a fuse blown, could be a fuse to the one of the modules is blown, it could be the signal screwed up, it could be one of the modules screwed up, or the electric motor controller. Any one of those things could be a problem. So then my next step is to isolate where the problem is. Now, in general, there's two ways to approach it. You can approach it from the control side, which is, turning on the blower motor and check to see everything's working there, right? Or you could do it on the far side, which is actually looking at the fan motor, starting there and checking that out. Of course, we check out fuses first, but yeah. Okay, anyways, let's take a look at the schematics. So here's the schematics, and it says, the first one right on the list, power, ground, serial data, that's the communication line, and front blower controls. That's where I sit. And so there we go. Here's my schematic, pretty straightforward. We got a fuse block, and it has two fuses, one for the blower motor and one for the HVAC control module. So go hunt those down, make sure those fuses are good, make sure there's power getting to them, etc., etc. So then what do we have here? We've got the HVAC control module, and there's other information you could dig around and figure out where that's located. And then we also have going through junction block. IP is instrument panel junction block. And then there is the blower motor control processor and the blower motor itself. So that blower motor has a connector, so an A and a B connector connect to the blower motor. So that's cool. So this schematic is very helpful for me. I can kind of start to suss out how this thing works. There's switches for the fan up and down, and then there is this blower motor speed control. So there's some type of a signal that comes from the control module to the blower motor control processor. This is just a speed controller here. And so that signal there, it could be a pulse, a pulse width modulated signal. It could be just a voltage level. It could be really fancy, like some computer, serial signal or something like that. Don't know. But that's what that says is. But then that controls this thing here. So a couple of other areas where this information is useful is, great, where's this control module exist? Where does junction block IP exist? Where does the blower motor control processor exist? And where does the blower motor exist? Where do these things exist? And inside our information, we have component location diagrams. So let's take a look here. We've got HVAC connector M views. So connector M views are almost always the ends of the connectors themselves, which is useful. This is great. But we just want to even see where the darn things actually exist. So this is not helping me a ton here. So let's see what else we can find. Cooling system connector M views, electrical center identification. Yeah, it's not really helping me much here. I'm going to try a different search term. Oops. I'm just going to try and go after HVAC and see what component. HVAC component views. Let's take a look there. Air temp. Module assembly. Top and bottom. Oh, there's the HVAC module. So this is where the whole blower and everything exists. All right, good. So this is the top of it. We don't want that. Let's check the bottom because that's what we can see. Bottom. There's the HVAC module. And number 3 there's the blower motor. And number 2 is the blower motor control processor. We can see a wire going to it there, and that kind of matches up with our diagram. That's cool. And I bet you this little guy there connects to that junction at the IP. Yeah, which is great. Okay, so what about the control module? Where does that exist? Control assembly, let's try that. Oh, there it is. So there's the dash, number 2 points HVAC control assembly. So that is the module. Is literally that display screen, and behind it, it's all circuit board, and that's the actual HVAC control module. Cool. And then the last thing we want to do is we want to look for IP junction. And so that IP usually means instrument panel. So let's see what IP junction is. Well, power and grounding component views. Let's see this. IP harness left side, upper left side of IP components. Let's see, IP. Let's see what we can get out of this. IP. Yeah, it's a tough one. It wouldn't be on the right side. It would be the right, sorry, the left side. It would be the right side. So let's see if we can. Yeah. Junction block IP there. I missed it. And there it is. So there's that junction block. Exists on, there's the dash with everything ripped off it. And the junction block simply exists at the dash. So the blower motor's under here. The dash exists right in there. We're all good. So that's how I use this information. It's very valuable, useful for these kinds of things. We've got wiring diagrams. We have the description and operation tells us how it all works. We have component locations for all of those components. We've got the wire colors. We can really start to get into this stuff. And it's all free. I do not have to subscribe to All Data or Mitchell or Identifix or any one of those things. It's all free. It's all the OEM stuff too. So there we go.